Hi, this video is going to be on multiplying and dividing rational expressions. So to start off, we actually have a multiplication sentence of two fractions that is not rational, and the reason being is just like when you simplify rationals, when they're actually similar to fractions, and the same thing happens with multiplying and dividing rationals. So for the first example, we have 5 over 8 times 4 over 15. So when we get started, we cross out 5 and 15 and we get 1 and 3. We cross out 1 and 4 and 8 and we get 1 and 2. And from this we can get 1 over 6. And for the rational example, what we first want to do is combine these two, this one and this one and this one and this one. But first, let me just rewrite the equation, as it may be confusing to some of you as of these signs. So it's actually 4x squared over 3xy and y squared over 8x. And from this we can make it all one fraction and get 4x squared times y squared and 3xy times 8x. And now from this, what we can do is we can multiply this by this, multiply this by this. So what we get from this is we get 4x squared y squared, 24x squared y. And from here we can we can simplify. So here we can cross the 4 and the 24 out and we get 1 and 6. These two are completely gone, and this is not completely gone, but this is 1 and then just y, like that. And from that we get the answer y over 6, which are the remaining values. And now what we want to do is we want to go back before we simplified, so here, and we want to find the non-permissible values. So from here we can see that x cannot equal 0 and y cannot equal 0. For the next example, we have 4x plus 8 over x squared minus 25 multiplied by x minus 5 over 5x plus 10. And for this one, we actually have to factor it first. So we get 4x plus 2, and then here difference of squares, so we get x plus 5 and then x minus 5, and we multiply that by x minus 5 over 5 bracket x plus 2. And from this we can cancel basically right away. So you can cancel this, and you cancel this and this. You get 1, 1, 1, 1. So from here we can get the answer, which is 4 over 5x plus 5. And if we go back, we can see that x cannot equal negative 5, x cannot equal 5, and x cannot equal negative 2. Now for dividing, and as you can see we have fractions yet again. So when we divide, we want to take the reciprocal of the second fraction and multiply the first fraction by that. So what that basically means is we get 5 over 3 and we multiply it by 6 over 1. And now we can simplify here. We get 1 and 2, and our final answer will be 10 over 1, which is equal to 10. So for this division one, it's a little bit more involved. However, it is not that complicated if you factor correctly. So from this we can get x plus 2, x minus 2 after factoring as a difference of squares. So we get x and then x minus 4, and we divide that whole thing by x plus 3 and x minus 2. And here we get x plus 5 and x minus 4. And after this step, we want to take the reciprocal of this fraction. So we keep this one the same. So we get x plus 2, x minus 2, and we have to multiply this by the flipped over version of this, which is x plus 5, x minus 4 over x plus 3, x minus 2. So preceding this, we want to combine the two fractions. So from here we get x plus 2, x minus 2, x plus 5, and then x minus 4. And in the denominator we get x minus 4, x plus 3, and x minus 2. And of course we gotta simplify again, so we can cross this out and this out, and we cross this out and this out. And afterwards what we write is x plus 2, x plus 5, as we just took the terms from here, which were not written, and in the bottom we get x and x plus 3. So now the last step is to find the non-permissive values, so we go back to before it was simplified, which is right here, and we figure out that x cannot equal -5, -3, 0, 2, and 4.